Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the middle of the linked list problem. Given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle. So, example, 1, 2, 3, 4, 5, 3 is sitting in the middle, 1, 2, 3, 4, 5, 6. 3 and 4 are both in the middle, so we return 4. There's a pretty obvious algorithm to solve this, which is we count the length of the linked list, we divide that by 2, plus 1 if it's a even number. Or, in fact, no. 1, 2, 3, 4, 5 divided by 2 is 2, I guess. So 0, 1, 2. And 6 divided by 2 is 3, so 0, 1, 2, 3. I guess that would work just fine anyway. But the point is, to compute the length of a linked list requires n steps, because you need to walk all the way to the end. And then you need to start at the beginning again and walk those n steps. So that's going to be order n plus order n, which is still order n. So it's not like it's asymptotically bad. You're never going to do better because you still need to walk at least halfway along the list. But it does require 2 traversals, which is wasteful, basically. It's unfortunate that you should need to go all the way to the end and then start over. What we can do instead is sort of a variation on this idea of a tortoise and the hare algorithm. And the way these work is you have not just one pointer working from the beginning and going to the end, you have 2 pointers. One called the tortoise, which moves 1 step at a time, it plods along, and one which is the hare. It goes very fast, it goes 2 steps at a time. And specifically, it's because one is going twice as fast as the other that we end up knowing where the middle is. So let's say I have my linked list. It goes 1, 2, 3, 4, 5. Initially, tortoise and hare are both sitting on 1. In the next time step, tortoise gets to 2, but hare gets to 3. In the time step after that, tortoise gets to 3, and hare gets to 5. 1, 2, 1, 2. 2 time steps, but the hare has gone twice as far as the tortoise. And sure enough, the hare is at the end, but the tortoise is only halfway along. So what happens if we do this with our 1, 2, 3, 4, 5, 6? Well, we'll start at the beginning, as usual. The tortoise only gets to 1, but the hare gets to 3. The tortoise gets to 3, and the hare gets to 5. The tortoise gets to 4, and the hare tried to walk off the end. So that's also telling us that we reached the middle. So that's what we want to do. We want to have the tortoise is equal to the head, and the hare is the head. While hare is not none, and hare.next is not none, the tortoise is equal to head.next, and the hare is equal to head.next.next. So the tortoise takes 1 step, the hare takes 2 steps. When we're done, the tortoise is sitting in the middle. There are some constraints here we need to be a bit careful about. There's between 1 and 100 nodes. So if there's 1 node, the tortoise's dot next is already done, so we're going to return. Sorry, the hare's dot next is already not. That's the wrong kind of hare. The hare dot next. Oops, this is tortoise, not head, and this is hare, not head. The hare.next is already none, so that's fine. So we stop and return just the 1. If it's even length, the hare is going to stop 1 before the end. So it can go next, and it will end up somewhere with none. But that's okay. Whereas if it's an odd length, it will end up somewhere with .next is none, and that's okay because we're not going to try and step beyond either of those 2 cases. So I think this works. It certainly passes the first one with 5. Let's use all the example test cases, but also put in our edge case of 1. Let's see what that does. Should work. I convinced myself it worked a second ago. Excellent. So if this doesn't make a lot of sense, I do recommend drawing this on a piece of paper. With linked lists, pencil and paper, or pen and paper, is easily the easiest way to try and understand them. They get so much easier if you draw it and actually sort of move your pens around, draw arrows, try and understand how they link together. It's when I taught in a classroom environment, definitely in a room full of computer scientists, they look at me like I'm mad when my first question when I came and helped them was, do you have pen and paper? But absolutely the best way to do it. Right, submit. Perfect. Solved. Excellent, nice little linked list problem. I don't love linked lists in general. This is one of those, it's only good for passing a coding interview style questions, but this tortoise and hare algorithm is pretty slick. And it generalizes nicely to significantly harder problems. There are problems like, can you find cycles in directed graphs and all that kind of thing, that you use exactly the same tortoise and hare algorithm for those kind of problems. Anyway, that's going to be it from me. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.